What? Okay, yeah. Hey, OMS, do the intro.
Say hello.
Oh, hi.
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 Say, all right. Good morning. Welcome to Calculus 2. All right. Anyway, crap. What do we, yeah. Anyway, area under curve. Talking about, yeah, man, seriously, my coffee is still full. Like, I've been sitting here the whole time trying to get to my coffee, and it's still full. So I'm like, oh, dang it. Brain not worky. Okay, anyway, all right, approximate area under the curve of the graph of function and find the area under a graph of function. So approximate, what does approximate mean?
What? It's gonna get negative. Let's get right there.
Wow, okay. What does approximate mean?
Get it close.
You get very, very close.
Very close, thank you. All right, so is it going to be exact? No. So is it going to have an equal sign? No, it's going to have that little wavy equal, right? The approximate symbol, right? Okay, good. All right. Find area under the graph of the function. So, okay, here is approximate the area under the graph of a function. So we're basically right here. This is the big idea 3 in AP Calculus. You guys actually have a big idea 4 for BC, but AB only has 1, 2, and 3. Finding the area underneath here. So let's take a look. So if I were to estimate this, because I'm doing it in a step right here, on this graph right here, what do you think? Do you think it would be an over or an under?
From left to right.
Just depends. Just look at the graph. Is it an overestimation or is it underestimation? Is there more over the line than there is
it looks like an
missing? So it looks like it would be over, right? Because if I'm looking here, I got about 3 steps over. So, oh man, come on, pen work. Okay, so I got this one that's over, this one that's over, this one that's over, and this one is under and under. So, looks like it should be an over, right? Okay. So I could actually say that would be an overestimation of the approximation area of that graph, right?
Yeah.
Yes. Okay, good. All right, so blah, 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 region, blah, formula. Okay, so we're just doing rectangles right now. That's it. Okay, rectangles. All right, so if f of h is my height, it's going to be that f of h is going to be where the function is at any single point. So at all points. So if I have a straight line, guess what? I get a rectangle. How do I find the area of a rectangle? Length times height, right? Okay, or base times height, width times height. So just depends. But what we're talking about here is curves. Okay, we're going to be talking about curves now for this. So it's not going to be a straight line. We're going to find it under the function. And the function is not just going to be a constant. All right. Okay, keep going. So for this one right here, we would actually, to get the area from A to B, I would actually have the area added of all 3 of those, right? Yes? Okay, good. So, okay, this is my n is equal to 3 for this. X, rectangular area. Okay, good. All right. All right, approximate the areas of the graph of the function. Approximate area A of the region closed by the graph, 12x plus 3, the x-axis, and the lines, x equals 2 and x equals 4. So that means that my left side is going to be 2, right? Right side is 4. That's as far as it goes, right? So if I were to do an overestimation, what side would I actually, I'm not going to do the graph part, or I'm not going to do like the actual integration of this. I'm just going to do a rectangle. So if I were to rectangle this, so let's box it in here, okay? So if I box that, what would my height be?
From which point? 5?
It'd be 5, right? So by boxing that, it would be 5, wouldn't it? Okay? Because look, it said over. Hey, you, that guy. It says overestimate first. It also says it on your paper too. All right, so overestimate first. So I boxed it from the top. So my height is what? 5, thank you. My height is 5. The height is 5. What is the width? 2. So an overestimation should be a area of 2 times 5, which would give me 10 units squared. Yes?
Yes.
Okay, good. All right, what about an under? Let's go under. I'm even going to change color on this one. Watch. Fancy.
Very rare.
Psh.
Don't forget to go up.
Huh?
What? I wanted to make a box rather than 2 boxes.
Oh no, you just scared me right there. Whatever that meant.
He wanted to drag a blue line up, that way it'd be like a little drawn box.
But it wasn't me.
It's not necessary, it's just kind of like an ocean.
All right, let's try this. Underestimation. What's the height of this? 4. So it's going to be area would be 2 times 4, which is 8 units squared. So that's an underestimation because I'm cutting off the top, right?
Yeah.
I'm cutting off the top. So all this is actually, I'm not including that, right? An overestimation means all this right here, which is not under my graph, but I'm going to include that anyway. So that's an overestimation versus an underestimation. Okay? So I'm estimating it right there with the width of 2. Now, make W equal 1 and now redo it. Okay. So I'm going to go make W equal 1.
You want 2 boxes?
Yes! 2 boxes. So if the width is 1, watch. Oh, right there. All right, so what's the value of the function at that point right there?
4.5.
4.5, right?
Yeah.
Oh, come on, work.
We'll estimate that.
Half of 3.
There we go. Okay, so yeah, in between those, so it should be, that point should be 3, comma, 4.5, or 4 and 1/2. Okay, yes?
Yes.
Okay, good. So let's start with the overestimation. So I'm going to overestimate both of these. So it's going to be this, and it's going to be this, right? There's my overs. So my area would equal my width, which is 1, times my height. What's the height to that? 4.5. So it's going to be 4.5 units squared. Okay, again, that's my next one. It's going to be my width is 1 times. What's the height of my second box? 5. So together, I come up with 9.5 units squared. Yeah? Okay. So there's an over. Let's do the under. There we go. All right. Oh, come on.
Not even computers.
I know, right? It's like my smartboard ran out of ink or something. So again, that's my 3, comma 4.5.
Message the IT guys. My smartboard ran out of ink.
I know, it's like blinker fluid. Yes, can you go get me some diet water while you're at it? Can you find me some Chemlite batteries? Okay. Get it, Chemlite, because it's a chemical reaction that lights up. There's no batteries.
Anyways.
Okay, chemical, chemical, no batteries.
This is math, not science.
Ah, man.
We don't care about your food.
Oh, I know. Seriously. Anyway, okay, so what's the height of my first one? 4. Thank you. So area is equal to the width of 1 times 4, which would give me 4 units squared. Next one, area is going to be, what's the height of the second one?
4.5.
1 times 4.5, which is going to give me 4.5 units square. So my total area is going to be 8.5 units squared. Okay. What do you think is actually closer to the actual values? Is it the when W is 1 or when W is 2? W is 1. Okay, it's smaller amounts of the overestimation and the underestimation. Okay, either way, that one's going to be closer. The more units, the more steps that you take, that's going to be closer and closer to the actual value. All right, approximate the area under the graph of f of x equals x squared from 1 to 10 by using lower sums. Okay, lower sums, so that means that's going to be the left endpoint of this. Okay, left endpoint. So when n equals 2 subintervals. Okay, so what's my starting?
0.
Okay, that's going to be right here, 0. And my end is right here. So no matter what, it's going to be in there, right? So, got to figure out how to find my intervals, right? So, I got to find it evenly, so I would do 10 minus 0 over 2 subintervals by 2. That's going to give me what? 5? So, each width is going to be 5. So, for my graph, I got to go, crap, let me see. 1, 2, 3, 4, 5. I think this one's 5. Yeah, okay, that works. Okay, so now 2. So now I'm going to do, okay, it says lower sum. So that means an underestimation, right?
Yeah.
So that means I'm going to actually have it from the left-hand side because the graph is going up, isn't it? So what's the height of the left-hand rectangle? 0. And then, all right, what's the height of the right-hand rectangle? Okay, so at 5, what is my...
25.
It's going to be 25, right? Yeah, it is going to be 25, because all I have to do is just plug in my x value. So it's going to be 5 squared, 25. So my area 1 is going to be my width, which is 5, times my height is 0. Area 2 is going to be my width of 5 times my height of 25. And so that gives me an area, total area of 125 units squared. Yes?
That's not very accurate.
Yeah, it's not, is it? Okay, so
Yeah, look at that giant chunk there.
okay, so now our next one we're gonna have is going to be so 5 intervals. So to figure that out, it's going to be again with the 10 minus 0 over 5, which is going to give me a width of 2. Okay, so each one's going to have a width of 2. So 1, 2, 1, 2, 1, 2, 1, 2. There we go. And again, if this is a lower sums, I'm always going to be looking at the one from the left, right? Okay, so how many? I should have 5 of these, right? Do I have 5 there? Yeah, I should have 5 rectangles. So let's see. So it's going to be, there's my 1. Here's my second one. Here's my 3rd, 4th, and 5th. All right, so to figure out the y values, all I have to do is plug in the x values, right? So the area of the first one, so area is going to be my width, which is 2, times the height. What's the height of my first one?
0.
Very good. Area of my second one is going to be 2 times, what's the height?
4. That's 2 squared.
Yeah, 2 squared, so it's going to be 4, right? Which is going to give me 8. Okay, so area of 2 times, the next one's going to be 6, right?
No, it's going to be 4.
Oh, I'm sorry, yeah, 4.
Yeah, those. So 16 times 16.
So it should be times 16, there we go. Which gives me 32. The area of my next one is 2 times,
Yeah. It's going to be 6 squared, so 36.
this one's 6?
Yes.
Okay, so it's 36. equals 72 area of 8.
Oh, 2 times 64.
64 is 128. So do you think that's going to be a lot more accurate?
It's gonna be more.
Pretty
so-
close,
Yeah.
but
It's a lot more accurate, isn't it?
Yeah.
Of the area under that curve. Yeah. So let me see. So it'd be all this colored in here, all this colored in here, all this colored in here. It's a lot better than the 2, right? So the more intervals I get, what does that tell me? The more accurate, the more closer to the actual value that your estimation will be. So, but the more subintervals we get, what does that mean?
more work.
Yeah, more work, right? God, nasty.
More color.
I know, more color.
Well,
Do you want me to do 10? Seriously?
I wanna see if
No,
there's
I'm good. I'm good. Right? Are you good?
Just take the regular integral so you get the actual.
Okay. All right. Anyway. All right. So basically, definition: area A under a curve. So this is the summation of those, of my delta x, because my delta x is going to get smaller and smaller. Remember, delta means the change. Yes? It's the change in the x value as that approaches 0. As that's going to approach 0, because I want my width in between every rectangle to be so small that it's approaching 0. It's eventually going to get there. So I'm going to take the limit as I do that. So as I get this, my delta x is this, okay? And my partitions keep getting smaller and smaller and smaller, okay? So right here, we should actually get the summation of these right here, okay? The summation of all of these getting to my delta x. So I'm going to have that many as it approaches. So it just keeps going on and on and on and on. So the area under a graph, okay, it's the limit of as n approaches infinity, because I'm going to get smaller and smaller. So I'm going to have an infinite number of units. So infinite number of rectangles. Okay? So I'm going to crap load of rectangles. I don't want to do all the work for that. Okay? That work sucks. All right. So of this function right here, of the summation. So I'm going to have that many rectangles. So that's what it means. So this is number of rectangles of this function of delta x, where delta x keeps getting smaller and smaller as that goes to 0. Okay? That's what all that means. I hate actually trying to read it like that. It's annoying. Anyway, all right. Finding area upper sums. Okay, so right here. So this says of the graph f of x equals 3x from 0 to 10 using upper sums, rectangles extended above the graph. Okay, the limit of all the sums right here. So basically, on this one right here, so however, I would take it of however many sums I have would be 10 over n, right? Yes?
Yes.
Okay, so it's going to be that. So my area would be this times my f of x, right? Yes? My f of x of the upper sum, right? So that would be of this. So if this is going to be my a and this is my b, right? So it would be from this side, the upper sum. So it's going to be the right-hand side of each one of these. So I could divide it amongst how many? So delta x is this times whatever my y is. So delta x times my function. It's my function, right? So it's the f of x, but where is the x going to be at? So if I had delta x, it's going to be f of some value, and that's why they put ci right here. That's an I, sorry. Ci. So it's whatever the function is, the delta x is ci of somewhere on here. So it depends on the amount of intervals I finally decide on. Okay? The amount of intervals that I decide, and I'm like, okay, this is my delta x, this is going to be this times whatever that is. Now, that's just Mathanese, just saying base times height. Okay? Right here. Okay, from 0 to 4 by using lower sums, rectangle lie below the graph right here, that is from here. Same thing. So from this one, lower sums, it's whatever my xi, okay? And the lower sum right here would be here, since the lower sum would be on this side, wouldn't it? Because it's not always increasing. Sometimes it could be decreasing. So now my xi is what I'm looking for. So it would be the xi, and this one over here would be whatever my xi minus 1, but that would be for this side over here, wouldn't it? So on all my intervals, it would be looking something like this. And these are all the functions I'm going to be using. Be whatever the xi is, depending on my delta x. Whatever the thickness of my rectangle is going to be. So again, just Mathanese. Just so you could actually, you know, if you see it, you're like, oh, what the hell? Yeah, so you're not like getting like a complete and total. You know, it's basically I just told you in Spanish how to order, you know, some tacos and go to the restroom. That's basically all you needed from all this. Okay? If you needed to like be like go into like some place that they only speak math and you're like, oh crap, I need to use a restroom. And you say, donde está el sanitario, right? But yeah, I know, but okay. So it's the area as limit of n approaches infinity of Sn. So it's infinite number of rectangles that has delta x, okay? Delta x as their width. So as that delta x keeps getting smaller, 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 okay, that's what we're trying to get to. Anyway, all right, there, okay.
We're down to the notes.
Bam.
We got it?
Yeah, you just got some basic areas to do, that's it. So if I was to find the area of this thing right here, what would I do to find the area of this thing?
Take the integral of the.
Bro, what shape is this?
It's a triangle. Based on
Thank you.
Take the integral of it.
It's gonna give you the same thing.
I know, but I'm trying to like. There was a problem on the AP exam. I think it was a BC that was something like this. They didn't actually tell you what it was. They didn't give you any function or anything. You just saw a shape. You're like, oh crap, what is this? It's a freaking triangle. That's it. You know, you're like, oh, okay. So my base is 10. My height is,
30.
and all that over. So it just came out to be 150 units squared.
Imagine me, AP kids were probably like, oh my god,
Oh, gotta
where's
find
the function to
integral or
integrate?
something.
No, seriously, like there is, and I remember because we were looking, we were talking about it, we're like, isn't that just a triangle? Yeah, I know there was a triangle one and there was one with a half circle. An area half circle, but it was on a graph. So you could actually see it like this, the graph, and so, right there, half circle. Okay, so do you need a function for that? Do you really need the function?
No.
So if my radius, so right here it says is 2, it's half the area, right? So it's the area over 2 would equal, was it pi r squared, and my r is 2, right? Because from here to here is 2. Yeah, so it would be 4 pi, right? It'd be 4 pi, and then so it's half the area, so we would end up getting 2 pi. That's all you have to do. Take the area divided by 2. Okay. Anyway, all right. Get to work. Y'all got some problems I just sent out? Y'all got like 15 minutes. Hey, don't forget, like and subscribe. Hit that notification button, right?